form up here. We have two different inequalities.
Wait,
Our first one is an OR. The second one is an AND. When we have an OR statement, we solve these as two individual inequalities. So we're going to first solve the left one. So Trey, how do I solve my left one here? Okay. Good. Subtract 4 from both sides. And then I have x is less than. What's 2 minus 4?
Negative.
Good, negative 2. Oh, that was nice and simple. Alright, we need to keep our OR there. You must have OR. If you do not put OR, you will get it wrong. Allow me to repeat that since Q1 and Alex are talking back there. You must have OR. If you do not have OR, you will get it wrong. When it's an OR statement, you must write your OR.
That's like writing an equation without putting the equal sign in. You can't do it. It's not right.
You can literally go.
Okay. Joe, what's the next step for this one? What do we do to both sides?
Plus 2.
Yeah, we add 2 to both sides. And what do we get when we add 2 to both sides? What do we get when we add 2 to both sides? X is greater than 3. Alright, so we have two different inequalities here. If we were to write this in set builder notation, it would simply look like this. Squiggle, X, line. X is less than negative 2, or X is greater than 3. That's all set builder is for these guys. Exact same thing as before. We have our squiggles, X, such that. Alright, drawing our graph for this. Alright. Again, I don't really care where you start your number line, just as long as you label it. So, here's my 0.
Make sure it's labeled sentence, or making sense, guys. A lot of you on the quiz like wrote 2 and 5 and then put 4 above 5.
Yeah, make sure you put that dot in the right spot. Alright, so we have an open circle at negative 2. Why is it open, Alex Hernandez?
Because
Why is it open?
It's negative.
Not because it's negative. Q1, why is it open?
Because it's told.
Because there's no line under it.
There's no line underneath it.
Because it's whole.
We use a solid dot only for the or equal to. Alright, and hey Sean, which direction is this arrow going to point? Good, to the left. As long as your X is on the left side, you can just look at your arrows here.
Is it?
Your inequality should be the same as your arrows.
Whichever one is on the left doesn't go.
Not always. Not
So are they gonna like?
They can't, but that's not something you deal with yet. So for right now, what we're doing, as long as you have if it's an OR statement, and you properly put these down, an OR statement should go in opposite directions. Okay, and Abdul, what type of circle am I going to have here, open or closed? Very good. So let's go to 3. And who do I want to pick on next?
Me.
Okay, Trey, which direction is that for? Let's get to 3.
He answers all the questions.
And here's our answer. And that's all we have to do. Any questions on this? Alright. So now let's take a look at number 2. This is an AND inequality. It's a compound inequality with AND, which means we should see that instead of our arrows going in the opposite direction, we should have 2 circles shaded in between. Alright, so with these, we need to do the same thing from all of our pieces. If it helps you to draw that line underneath your inequality, by all means go and do so.
Subtract 2.
Yes, subtract 2 from both sides. And then Kajo, I'm going to call on you next. So notice we're subtracting 2 from all 3 pieces. 14 minus 2 is 12. So we're less than or equal to. 3h. 2 minus 2 is 0. And 2 minus 2 is 0 over here. That's fine. We can put a 0 there.
Okay.
Alright, Patrick, what's my next step? Good. We're now divide by 3. Again, from all of our pieces. What if this 3 were a negative? What would I have to do? Switch what? Right. Very good, Alex. If we divide or multiply by negative, we have to flip our signs. Alright, 12 divided by 3 is 4. These signs stay the same, though, because these were positive 3's that we divided by. That reduces to 1h. And what's 0 divided by 3? 0. I have 0 cookies to give to 3 people. Each person gets 0 cookies. I'm pretty sure. Alright. So let's do our number line next. And again, if it requires to do set builder notation for this is still the same type of idea. X such that we just write our entire inequality. Oh, you're right. Trey caught a mistake I just made. We're using H, so we need to use H. Such that. Very good. Such that 4 is less than or equal to H, which is less than 0. Alright, so now let's graph this. Our 2 endpoints. We have 4 and we have 0. Miss Charlotte, did you see the mistake on this one in first period?
Yeah.
Anybody see the mistake with our original problem? Yeah! 2 is not bigger than 14, is it? So, technically what the original problem should have been is our inequality should have faced the other way.
Yeah, we talked about that because there are still sometimes on the SL where they'll see it that way.
I haven't actually, so technically.
Alright, so technically our inequality should have been the other way. Sorry about that, guys. Because 0 is not bigger than 4. Alright, so if we, again, remember, we talked about this last class, if your largest number, or your smallest number is on the right, let's go ahead and flip the entire inequality. 0 less than h, which is less than or equal to 4.
And guys, please make sure you pay attention to who's being eaten. So up there, h is being eaten instead of 0, so that still needs to be the case on the bottom. And 4 is being eaten instead of h, so it still needs to be that way on the bottom.
Yep, 0 is less than h. H is being eaten, so h should still be eaten. 4 is being eaten, so 4 should still be eaten. Alright. So 0, 1, 2, 3, 4. Alright, Rachel, what type of circle am I going to have on my 0? Very good, open. And Morgan, what type of circle will I have on my 4? Very good. And Sabrina, where am I going to shape? Where should I draw my shaping? Yeah, in between. Very good. This is an and statement. It's all smushed together. It's one big sandwich, so we should have our shaded in between. That's probably into there. Again, notice I labeled my number line and I marked where my circles were and what numbers those were. Questions on that? Okay. Let's go over homework before we take our mini quiz.
Promise you can handle it.
So last class, we were talking about compound inequalities, or statements and statements. Today what we're talking about is when we have x and y, how to graph these inequalities. Before we were dealing with just one variable, now we have 2 different variables and we'll be graphing these. So it's very similar to how we graphed an equation such as y equals 2x plus 3. We still graph that same line, just now we have shading with it. Alright, so starting off at the top of your notes, and everyone should be writing this down. A solution is an ordered pair that makes the inequality true.
Yeah,
If we have a graph, the solution is on a solid line or in the shaded area. And we should not be talking, we should all be writing this down.
Came unfair.
Didn't you just get one from me at the start of class? I'm pretty sure it was.
It's right there in front of your chat paper there if you want.
Yeah, there's another one.
It's on the desk in front of you.
What do you call it? Traffic?
Okay, so notice this is only on a solid line. If we have a dotted line, the dotted line itself is not a solution. So if there is a dot, if they're asking for a solution that is on the dotted line, it does not work as a solution. Only on a solid line or in the shaded area. So let's take a look at number 1. It says, is each ordered pair a solution of the inequality? All right. So we need to go ahead and take each of these and put them in for x and y. We have x and y. So we're checking 2 different points here. So for this first one, both x and y are 0.
How many subscribers do you have on your YouTube channel?
All right, so we put in 0 for x.
2.
So it's 0. 0 for y.
0.
And that's greater than -3. So we're checking, is this greater than -3? What's 0 plus 0? And is 0 greater than -3?
Yeah.
So we know that this is a solution. So we have 0, 0 is a solution. We're just checking to see if it works in our inequality. Does it ask, is it a solution? So you check to see if it's a solution, you check to see if it works. All right, Joe, what do I do with the next one? -6 and 3. What do I do with this?
Just gotta like plug it in.
Put in where?
The X and the Y.
And what's going in for x?
6.
-6.
Oh my gosh.
Oh my god.
We have some people that are still struggling knowing which one's x, which one's y.
Remember, it's alphabetical, guys.
Minus
X comes
40.
before Y in the alphabet, so X comes before Y in your ordered pair.
Alright, so we have -6 for x. And Tayshawn, what's my y by?
3.
Good. And we're checking to see, is this greater than -3? It's -6 plus 3.
-6 plus 3 is 3.
Close.
Negative.
-3, good.
Good job, Abdul.
Is -3 greater than -3?
Yeah.
Equal.
It's equal, but we don't have the or equal to, do we?
So it's not.
It's not true. It's not greater than that, so it's not a solution. So that point, -6, 3, is not a solution.
Guys, last class we seemed to do really well. This class we're talking consistently our graph teaching. That's not okay. It's very rude.
That wasn't me.
All I did was look in that area and you made eye contact.
You said my
Never
name.
said, I said gentlemen.
You said Joe.
I said gentlemen.
She said gentlemen, guys.
So, right now, you are still talking more than anyone else who's been arguing like this. You need to stop.
Alright, so number 3. Let's take a look at this one. They already gave us the graph for this. So our solution is something that's either on the solid line or in the shaded area. So they ask about the point 1, 2. Alright, so I go over to 1, 2, and I put that dot on my graph. Is that in the shaded area or on the solid line?
On the line.
I think it's actually a little bit in the shaded area.
Yeah.
So 1, 2 is in the shaded area, so I know that 1, 2 is a solution.
We don't have to solve it.
Since they gave us the graph, we don't have to solve it. Alright, let's check 6, 1. So I go over 6, up 1. Is that in the shaded area or in the solid line? Yes, so that is also a solution.
There's a guy behind you.
Alright, so again, if it makes the inequality true, it's a solution. If it's in the shaded region or on the solid line, it is a solution. putting it away?
Put my pencil away. I was using my pencil.
You have your phone out, actually, sir.
I believe that's fun.
That's my pencil. Yeah.
All right. Any questions on this? Okay. So now let's take a look at how to actually graph. So graphing inequalities in two variables. All right. So sometimes they give it to us already in y, but sometimes not. So.
No. You gotta move it.
I just
All the way by yourself.
looked at her.
Can you handle these?
I can handle it.
Alright, so we need to solve for y if it's not already given to us in y. Let's try this again. If it's not already given to us in y, then we need to solve for y, just like we've been solving for y all along. Then you need to identify your slope and your y-intercept. Remember, your slope is the m value, your y-intercept is the b value. Some of you guys are still getting these flip-flopped. So identify the slope and the y-intercept.
Yeah, this is good. Yeah, me too.
Alright? Plot your y-intercept, the b value, and then count your slope and plot 2 more points. We still have people that aren't properly graphing these lines, so make sure you're paying attention to this. So you first put your y-intercept, and then from there, you want to take your phone, turn off the phone, put it
Turn it off. Yes, it's now.
away.
It's not.
Just put it away. I don't want to see it over. After we've plotted our y-intercept, we then, from there, use our slope to find our other 2 points. Alright, after we do that, then we have to decide what type of line to draw. Because we can have a solid or a dotted line, and we can shade either above or below. So in order to decide all this information, we need to look at our inequality. Our inequality is going to tell us whether it's a solid or a dotted line. Our shading is going to tell us whether we go above or below. So if we have an equal to, a less than or equal to, or a greater than or equal to, then we draw a solid line. If we have an equal to, a less than or equal to, a greater than or equal to, we draw a solid line. What do all 3 of those have in common? What do all 3 of these have in common? Or equal to, right? They have some type of equals with it. Alright, if we have a less than or a greater than, what type of line do you think we'll draw?
A dotted
A
line.
dotted line. Notice these have absolutely no remnant of equal with it. So if it has a less than or greater than, then we draw a dotted line. So we look at our inequality to know, you don't got there yet. We look at our inequality to know whether we do solid or dotted. Okay, so once we've graphed our line, then we need to figure out which part of our graph to shape. In order to do that, we need to pick a test point.
Chill. It's not funny.
Our test point needs to not be on our line. Remember that if a solution works, that should be in the shaded region. So what we're going to do is take our test point and check to see if it's a solution. If it's a solution, we shade that part of the graph. If it's not a solution, we shade the other side. Alright, so we pick a test point and determine if it's a part of the solution. So we put it in our inequality. So put x and y in the inequality. We're checking, just like we just did in that first problem. We're checking to see if it's a solution. If it is a solution, then we shade that side. Because remember, solution should be within the shading. If it's not a solution, then we shade the other side. It should not be within the shading. So we graph it, draw either dotted or solid, take a test point, and that tells us our shape. Okay, Sean, are you writing this down?
Are you?
You got it all right. Alright, questions on this before we do an example? Alright, so we're going to start off with number 4. Notice we don't have a y here, so we are going to solve for the only variable that's given to us, so x. And how do we get x by itself for this problem? Divide by 4. So this is just like what we were doing last class, where we're basically solving it. My 4 is reduced to 1, so I just x is less than negative 12 divided by 4 is negative. Why did I not flip my inequality? Right, I divided by a positive 4. Even though 12 is negative, I'm not dividing by negative 12. I'm dividing by positive 4, so it stays the same. Alright. So think back to, I think it was unit 3. When we had just x equals or y equals, we had the following acronyms. We had thus, and we had what? Which one are we going to use here? Thus. Yeah, it's x, so we're going to use the x. What type of line is it if it's just x? It has an undefined slope, but what type of line? What does the line look like? It's a vertical line. So when we graph this, we'll be graphing a vertical line. Okay, so we need to decide, is it solid or a dotted line? Dotted, and how did we know it's dotted? Right, there's no or equal to with it. So it's going to be a dotted line. Alright, so let's go ahead and graph this line. Joe, head up, please graph it. Alright, so we know it's going to be a vertical line. And we're at x is negative 3, so negative 1, negative 2, negative 3. So this is where I'm drawing my line. It's a vertical line because it's x equals, but really it should be dotted, right?
Yes.
So you need to make sure that you draw a dotted line. So we've drawn our line x equals negative 3, but we need to check to see which side we're going to shade. So you can pick any point that is not on the line to test. My recommendation is to pick 0, 0 if that's an option, because that's going to be the easiest thing to check. It's easiest to put in 0 and see what your result is. So whenever 0, 0 is not on your line, I highly recommend just use that as your test point. So let's test 0, 0. Right. So that means x is 0 and y is 0. So we need to check. Alright, so go back up to my original inequality here. So I have 4 times 0. So then if there's no y, there's nowhere for us to put the y, so we don't use it. 4 times 0 is less than or equal to negative 12. We need to check to see if this is true. And 4 times 0 is? 0. Is 0 less than negative 12? No. So this is not a solution. So the point 0, 0 was not a solution. So that means I need to shade the other side of my inequality. You can pick any ordered pair on your graph that's not on the line. I usually just pick 0, 0 because that's the easiest thing to simplify. Alright, so I need to shade the other side of my graph. So 0, 0 is here. I need to shade the other side. So I shade everything over here. Okay. Now our solutions is any ordered pair within my shaded region. Anything over here is a solution to my inequality here. So we're going to go and just list a couple of them. And your answer might be different than the person next to you, because again, we have an infinite number of solutions over here. So one of our solutions would be, I don't know, how about this, negative 1, 2, 3, 4, 5, 6, up 2. So x is negative 6, y is 2. So the point negative 6, 2, that falls in my shaded area, so it is a solution. Alright, so what would be another solution to my inequality here?
Negative 5.
Negative 5 what? Good. Negative 5, 4. 1, 2, 3, 4, 5. Up 1, 2, 3, 4. So negative 5, 4 falls in my shaded region. So I have that's for my solutions. Yes. Yeah, so this part here, that's my original inequality. So x is 0 and y is 0, so I put 0 in for x. Good question. Alright, other questions on this problem? Okay, so let's take a look at number 5 then. So number 5, we have negative 4y is less than 8. You need to get y by itself. Alex Hernandez, what do you think we're going to do? Good, divide by negative 4. Divide by negative 4 on both sides. And Tayshawn, when I divide by negative, what do I have to do? Switch what? The sign, the inequality. Good. When we divide by negative, we have to flip our sign. Joe, please write this down.
I do.
You have done nothing on the problem, by the way.
Yeah, I did.
So we have y is greater than negative 2. Alright, is this going to be a solid or a dotted line? Good. It's going to be a dotted line.
Yes.
And so why is it dotted? Because there's no or equal to.
Oh.
So dotted line is when it's a plain old less than or greater than. Alright, so again, using our acronyms, because we only have y here. We only have one variable. So going back to was and oi, which one are we going to use? Right, we're going to use oi because it's y. So what type of line is that going to be, Joe?
Horizontal. Horizontal. You're welcome.
So we know this is going to be a horizontal line. So let's go ahead and graph this. Now we know it's a dotted line. And it's at y equals negative 2. So I go where y is negative. Negative 2.
Looks amazing.
So here's negative 2. I'm going to draw my line through there. And again, it should be a dotted line.
Why?
Why should it be a dotted line, guys? We just said this. Alex, why is it dotted line?
Because it's not a less than or equal to.
Right, there's no or equal to underneath it.
Thank you, Alex.
Alright, so let's pick a test point. Again, 0, 0 is the easiest one. 0, 0 is not on my line, so we can use it. 0, 0. Let's put this into my original equation. My original equation was negative 4y is less than 8. So we have x and y. So negative 4 times 0. What's negative 4 times 0? And is 0 less than 8? Yes. So this is a solution. So go to where 0, 0 is, and that's going to be part of my solution set. So again, we shade the part that has it.
Has it?
Yes, because it is a solution, so we shade that part.
It looks like a crayon.
Owen. So again, since 0, 0 is a solution, I shade that side of it.
I see.
Why is it a crayon?
Because I changed it to a crayon.
Bam. Oh, she's being sassy.
Never again. And that never again.
Alright, so now we need to write solutions. So that's going to be something that's within my shaded region.
Yes, Dave.
Joe, what's going to be one of my solutions?
You know.
Yes, I do know, but I don't know if you know.
It could be anything in the shaded area.
So pick something in the shaded area.
How about pick any number. 0 and 4.
0, 4. Let's go to 0, up 1, 2, 3, 4. And indeed, that is a solution. Guys, what's another very easy one we can say? 0, 0. We used it. We know it's a solution. You might as well save yourself some time and put that in as an answer.
Sorry.
So anything in the shaded region. All right, questions on that? All right, we're gonna do number 7 next. Which is y is greater than or equal to 2x plus 10. Here we have both y and x. So we know it's gonna look like a line that has some type of slope to it. And it's greater than or equal to. So since it's already, y is already by itself, we don't have to move anything around. Alright? So we don't have to do any work for this. Let's go ahead and identify our y-intercept and our slope. Abdul, what's my y-intercept? And Abanya, I'll ask you myself. Abdul, what's the y-intercept? Good, 10. Great, so let's go ahead and put that on my graph. Let's go to y is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nope. Alright. And Evanya, what is my slope? Good, just the 2. We don't need the x one. Okay. So my slope is 2. And remember, 2 is the same thing as 2 over 1. We need both pieces so we know how much we have to rise and run. Tayshawn, what's my slope?
2.
Which is? No. 2 over 1. It is positive, so we should see our line going in the positive direction. Alright, so it's up 2 over 1. Notice we end up going off the graph. So let's instead go down 2 over 1. Oh, I forgot. This is off. Alright, so down 2 over 1. And you do at least 2 other points. Down 2 over 1. Again, we could go up 2 over 1. We're just off the graph at that point.
Is that the homework?
Nope.
What's the
Alright, so is this a solid or a dotted line here? Solid line now, yeah. We have the or equal to, so it's going to be a solid line. Alright, so let's draw our line through here.
Okay.
All right. And our test point is 0, 0 on the line. So let's use that. The easiest test point in the world. Let me know when you find an easier one.
Nice.
You have to do more work with that. All right, so again, we have y is greater than or equal to 2x plus 10. So we put in 0 for y, greater than or equal to 2 times 0 for x, plus 10. Okay, so we're checking. What's 2 times 0? 0, and 0 plus 10? Is 0 greater than or equal to 10?
No,
No.
not from.
So it's not a solution. Okay, so 0, 0 was here. This is not a solution, so I shade the other side. I shade the other side.
It's a crayon.
So,
Wait, didn't she color the wrong side?
no.
Aren't you supposed to color the 0, 0?
Why do we not color the 0, 0 side, class?
It wasn't.
It wasn't a solution.
Ah.
So now let's list answers that are solutions. Naaman, I'm going to call on you for one, and then...
Joe.
All right, Naaman, go ahead and give me a solution. Sorry, I think it was just... Did you get 10-1?
The only time we don't use 0, 0 as our test point is when it's really, really, really close to the line. If you want to be careful about choosing one that is very obviously in the shaded area, probably a good choice.
Yes, whenever 0, 0 is on the line, you do not use it, because you cannot use a point that's on the line. Okay, and Tayshawn, what's another solution? Anything in the shaded area.
Yellow crayon.
That's actually orange.
First.
Negative 9, 2.
What I put.
Negative 9, 2. Very good.
It's yellow.
It's actually orange.
I mean,
This is called yellow.
we could meet in the middle at a solid, like, mango color.
I'll go with that. Okay, questions on this one? Yes, no. So, Naaman wanted to know how do we know which side is colored in. So we tested our point 0, 0, and it was not a solution. So I'm going to shade the other side. 0, 0 is here. 0 is not a solution, so I shade the other side of my graph. All right. Other questions on this before we move on? You with this Q1 now? All right, next problem.
Why is this
All right, number 8 says x plus y is greater than 8. So we need to get y by itself. How do I get y by itself? Joe, how do I get y by itself?
What you gotta do is you gotta do that. Minus X.
Very good.
Thank you.
Subtract x from both sides. So we have y is greater than negative x plus 8. You write it in this format, keep it in that slope-intercept form. Remember, slope-intercept form is y equals mx plus b. We're mimicking that form to make it easier to graph. All right, so my y-intercept. Kevin, what's my y-intercept? What'd you say? What's my y-intercept? And then Alex, I'll call on you for this slope.
Okay.
Good. My y-intercept is 8.
Come on, Q1.
My y-intercept is 8. Alex, first use. What is my slope? It's what's in front of x. What's in front of x? -1. So remember, if we don't have that coefficient in front, then it's a 1 there. So I have my slope there. My slope is -1, which is the same thing as -1/1. Alright, let's go ahead. Oh, well, first let's figure out if it's solid or dotted. Joe, is this going to be a solid or dotted line? Yeah. Abdul, why is it dotted? Good, it doesn't have the or equal to underneath. Very
You
good.
didn't say anything.
Yep.
You just like, you know, it's the thing.
It's only more than you.
Oh.
Why are you guys owing that? Alright, let's graph our line. So we have our y-intercept is at 8. 1, 2, 3, 4, 5, 6, 7, 8. And we should all be graphing this. And my slope is -1/1. So down 1/1. Down 1 to the right 1. Down 1 to the right 1. We could do this all day. Well, I'm not going to. You can. And remember, guys, if our slope is negative, it should be going down as we go to the right. That's something you can do to check to make sure you did your slope correctly. Over here, my slope was positive, so it should be going up as I go to the right. Here, my slope is negative, so it goes down. All right, we said this is a dotted line.
Oh, that's it's dotted, why don't you just put a line over it?
Because I'm changing it to dotted, just like I did for all the other ones. Alright, so let's go ahead and do a test point. Is 0, 0 on the line? Oh, let's use it. That's the easiest one.
Change.
Alright, my equation was x plus y is greater than 8. Here's my x, here's my y. 0 for both. What's 0 plus 0? Is 0 greater than 8? 0 is not greater than 8, so it's not a solution. So again, 0, 0 is not a solution. So we shade the other side. So we shade the other side of my graph. Alright, let's go ahead and pick a solution. Joe, you'll give me one, and Tayshawn, you'll give me another. Tayshawn, what's the solution?
10, no, 10, 3.
Alright, over 10. 3, 4, 5, 6, 7, 8, 9, 10. Up 1, 2, 3. Good. And Joe, what's another solution?
93.
Good. Alright, next one. We have 4 minutes.
That's a long little time.
We could do our
Alright,
homework.
let's go
Let's do next
to
time.
number...
Wait, Miss Margaret. Miss Margaret.
That's what I'm thinking.
Alright, number 10. I want you to go ahead and solve that for y.
Yeah, in my head.
You did in your head. Solve it for y.
Why can't we do our
What?
Can we do our homework while we have this?
Solve for y. Solve for y.
What? No, I drew it myself.
What?
That's your fault.
You're the one that's laughing and rolling in your chair. Alright, what's the first thing to get y by itself? Divide
Wait, no,
3?
no.
You gotta move that whole chunk over.
Oh.
We've got to move the whole 3x over, right?
No, subtract it.
Subtract 3x.
I said 5.
So I have negative y is greater than or equal to negative 3x plus 5. Is y by itself though?
No.
No, what do we still have with it?
-1.
A negative 1. How do I get rid of that negative 1? Divide. Yeah, divide by the negative 1. You can just divide by negative 1. And what happens when I have to divide by negative? Flip the sign. So now let's do our I heart division.
Do it again. Do it again.
I have 3x minus 5. And then you will continue on from there. Questions on that?
So,
Is this the homework?
what is the homework?
Alright, I'm going to pass out your homework to you, and I'm going to pass out your tests that you took before break. A lot of you will definitely want to retake this, so make sure you come after school to work on corrections so that you can retake